Hello everyone, welcome back to our Solidworks course. In this video, we would be taking up the first exercise for Revolve, shells and reps. In this exercise, we would be generating a 3D model using the Revolve command. Also, I would be giving you an introduction to using sweeps. Also, in this video, I will be showing you how to create different types of planes, or as it is called in SolidWorks, reference planes. Let's take a look at our model for this exercise. Here you can see that we have a simple steering wheel. This would be generated using Revolve. And the spokes of a steering wheel connecting the boss to the outer wheel would be developed using sweep. And also we will be taking a look at how to emboss this title over here that says SolidWorks on our components. Let's move to SolidWorks and get started with our exercise. We have launched SolidWorks and we will create our first feature. For that, I will go to the front plane and get into the sketch mode. I will first create a center line, as we know that in order to create a revolve feature, we always need to specify a center line. Let's say I draw my center line over here from the origin. Next, I will select a slot and then give it its dimension. Let's say I want my slot over somewhere here. I will place it there roughly and then define it using dimension. You can see here, while creating the slot, there are dimensions already specified or already added. We just have to modify it. Now here I will also show you that while you are in the MMJ system of units, you can enter your units. Let's say I am in the metric mode right now, but I want to input the units using inches. What I will do here is that I will simply double click on our dimensions and here it pops up the modify tab. Now here let's say I want to input the units or input the dimension as 1.5 inches. What I have to do is that I have to simply enter IN in front of 1.5 and you can see that the dimensions have been entered and the dimensions were entered in inches, but here they are specified as millimeters. You don't need to go and convert your dimensions first and then come back to SolidWorks and enter them here. SolidWorks, as we have discussed earlier, is a very user-friendly software. I will delete this dimension from here because I want to specify the entire width of my slot. For that, I will get back into the Smart Dimensions tab and then I will first press my Shift key and select this curvature. Then again, by pressing the Shift key, I will select this other circle or the curvature over here. Why did we press the Shift key? Is because by using Shift, we can use the most extreme point on this curve over here. I will delete this dimension here and show you what will happen if I don't press the Shift key. Now I have not pressed the Shift key. I will select this curve again and I will select this curve again. You can see that if I had not pressed the Shift key, it provides me dimensions from the center of these curves or arcs. But as I want the dimension to be from the extreme edges, I will press the Shift key, select this curve. Again, by pressing the Shift key, I will select this curve or this arc over here and I will specify my input parameter as 2.2 inches. I will write 2 and in front of that I will enter IN. You can see here that again my dimensions have been converted to millimeters and presented over here on the screens. Now I have to specify or define the center point of this arc. For that, I will select the center point and then select our origin. We will always define our sketches from the origin. Let's say I enter here 20 millimeters and I give the horizontal distance as 200 millimeters. Once I have done this, you can see that my sketch has been completely defined. Now I will go to features and select revolve boss from here. Now it is asking us the axis for our revolution. For that, we will select this axis that we have created and you can see here that it has already selected the contour automatically. Now once we are Done with giving all the input parameters, we will simply click on OK and generate our revolve. You can see here that just by sketching a slot and a center line about which this feature or this sketch should be revolved, we have created this loop over here. This is how you can use these features in order to create your 3D models quickly. Next, we would be creating the center boss again with the help of Revolve. For the boss in the center, what we will do is that we will simply create a rectangular profile. Again, we'll get into the front plane and sketch on it. I will press Ctrl 8 and set it normal to our screens. Now here, I will select a corner rectangle and draw a corner rectangle somewhere over here, roughly placing my sketch. I will zoom in so that we have better control and better access to our entities. I will get into smart dimensions and first define our rectangle. The height for a rectangle is 40 millimeters and the width of a rectangle is 30 millimeters. Next, I will specify the distance of my rectangle from the origin over here. I will specify the distance from this line or this side of the rectangle up till the origin. I will click on the screen and then enter 50 millimeters as the distance. Next, I want this line at the same level as our origin. For that, I will select this point over here and again select this point over here. I will first escape or exit the smart dimensions command so that I can give relations. Again, I will select this point, press Ctrl and then select our origin point. We will set this as horizontal. Now you can see that our sketch has been completely defined. Again, we will follow the same method. That is, we'll go to features. From here, go to revolve boss base. And next, we just have to specify an axis of rotation, revolution. But in this sketch, you have noticed that I have not drawn an axis. That is because I will use the axis that we created in the previous sketch. We can always use references from the previous sketch. You can see over here that I just have to make the sketch visible. For that, I will exit revolve and rebuild the sketch. Now I will go to the expand menu over here, click on the sketch and then click on the eye over here that says show. Again, I will select my latest sketch and go to edit sketch over here. Now you can see as I have shown my previous sketch, the sketch is now visible and I can use this axis as my axis of revolution again. Again, I will go to features and select revolve boss base. Here you can see that this is taking it as an axis of revolution even if I have not created in this sketch. This is how you can use dependency in Solidworks. You don't have to create the same feature or the same sketch again and again. You can save time in this. Now what I will do is that I will simply click on OK and generate our boss. Now you can add some fillets over here. Let's say I go to fillets, select constant size fillet over here and select the edges on which I need fillets. I select all these edges over here, this one and this one itself as well, and enter the value of fillets as 2 millimeters over here. I will enter 2 and press the enter key. You can see that a preview is being shown as to how our fillets would be generated. I will click on OK and you can see here that our fillets have been generated. Now we will begin with creating the spokes of our steering wheel. I will set this to isometric by pressing Ctrl 7 and you can see here that it has been set to the isometric mode. But before going further, I want to show you how do we create planes. For that, let's get into another part and see how can we create planes, because it is very important to create reference planes so that you don't have to add n number of dimensions. You can simply sketch on the planes or the face that you want and continue with your sketch. We will start learning about creating reference planes with the help of this 3D geometry we have over here. If you remember, this is the 3D geometry that we have generated previously. Now, in order to create a plane, we will go to the drop down of reference geometry and then select planes from over here. Here you can see that we have options to provide references. The most easiest one is to provide a flat surface and give it offset. Let's say I want this plane at a distance of 21 millimeters. You can see as I enter 21, the plane is now at an offset of 21 millimeters from the surface that I have selected over here. Next, instead of providing an offset, I can also give it an angle. Let's say 90 degrees. Now you can see that the plane is now shifted to 90 degrees from this face here that we had selected or given as a reference. The next option we can see over here is to set our plane perpendicular to the face that we have selected. If I set perpendicular, you can see that this is how it would be created. Next, we have the coincident option. In this, let's say I specify some vertices. From here, I will first delete this and select this vertex from here. Next, in the second reference, I select this vertex over here. You can see that the orientation of our plane is being changed as I'm adding more references. Let's say the third vertex that I select is this one. Now you can see that this plane has been formed at an incline and all these points are coincident. That is, the plane is coincident to all these points. This is how you can use the coincident command in order to define your plane. The next option over here is to set the plane at an angle to some edge. First, I will delete all these references from here, the first one as well, and in the first reference, I will set this edge as my reference. You can see that this is creating a plane at this edge over here, and now it is coincident to the edge. If I select perpendicular, you can see that now the plane is perpendicular to the edge that we selected. Next, we will take a look at how to create a plane using a line and a vertex. Let's say you want a plane perpendicular to this line over here, but you want the center of the plane to be at this vertex over here. In the second reference, I will simply add this vertex as my reference, and you can see here that the plane is being generated from this vertex over here. I will show you what happens if I click on OK before we move to the other options, as we are only in the preview tab. If I click on OK, you can see that this plane has been created. A new feature rather, is added over here, and it shows that this is a plane at this location. You can see that it is perpendicular to this line and is starting from this vertex or this vertex over here. If I again go into the edit plane command, I can see that I have only some more options. We will explore them as well. Now first, I will show you how to create a plane at an angle. First, I will delete all these references over here. Now I will show you how to create a plane which would be at an angle to this face, but it would be starting from this edge or would be coincident at this edge. You can see now for the first reference I will enter this face. For the first reference I will enter this face, and in the second reference I will select this edge over here. Now that my edge has been selected, you can see if I click on the reference tab over here, it is showing me the edge that I have selected. If I click on here, it is showing me the highlight of which face I have selected. Let's say I want it at an angle. I want it to be at an angle, say 60 degrees to this face. Once I have entered 60, you can see that my angle or the angle between the plane and this face is 60 degrees. If I simply enter 90 degrees here, you can see that it would be in the same plane as this line or this face on the top over here. Let's say I want to end it at 45 degrees, and I will simply enter 45 and my new plane would be created. Next, I will show you how to create another plane with a face as my reference, and the second reference would be my edge over here. Now you can see that as I am changing my references, the type of planes that are being created are being changed. The aim of this demonstration over here is that you have to create the right type of plane you would be required in order to model your 3D component, whatever the necessity of the model is. You have to use your creativity and use the right options in order to create these planes. There is no specific situations wherein you have to select these two options only. There are multiple options that could work for a single operation or a single use. Now in here, These points are as the name suggests are just reference points. Now I will specify this vertex as my second reference, but it won't be created at an angle. I will have to make it parallel. Now here you can see that the plane is parallel to this face over here and is starting from my vertex that I just selected. This is how you have to play with your references in order to create your plane. And while modeling, you have to keep your design intent in your head and create these planes accordingly. Next, I will show you how to create a plane tangent to the surface using curved surfaces. Now, I will first clear this from over here. We'll select delete. Now, in the first reference, I will select this plane. Now you can see that as soon as I've selected a curved surface, it will directly generate a plane which is tangent to that surface. Now what I can do here is that let's say I want the plane to be tangent to the curve, but then I want it parallel to this face as well. Here it is selected perpendicular. If I select parallel, you can see that now it is tangent but parallel to the face. Next one is the one we saw before. Here you can see that it will be perpendicular to the face that we selected in the second option, but at the same time it is being tangent to our curved surface. Next is a coincident reference. Here it cannot be coincident and be tangent at the same time, because you can see that there is a difference or there is a space between these two entities or these two surfaces that we have selected. If I zoom in, you can see here that in order to be tangent to this curved surface, this plane has to always be in this vicinity over here. If I make it coincident, you can see here that the plane would be created at this distance from the curved surface and will no longer be tangent. So you have to smartly use the options shown over here. You can't just select any random options and expect your plane to be created. That's why I told you need to have your design intent in your head always. If I get back to perpendicular, you can see that now this plane can be created easily because this is perpendicular to this face, taking one of our definitions that we've added over here, and next definition is being tangent. You can see in order for it to be tangent, it always has to be in this area over here, touching this curved surface. If I set it to isometric again and move forward with our next type of plane, but for that I will have to delete these references from over here. If you don't delete it, you can simply just click on this and then add and then select the next reference that you want to add. Let's say I want to add this face as my reference. You can see here that it has replaced our previous reference automatically. I have selected second reference. For the first reference, I will select this plane over here and then make it parallel. Again, from here I will select parallel option, and then we have to turn on this option that you see here that says mid plane for this one as well and for this one as well. Now that I have turned on the mid plane option, you can see that a mid plane is being generated between these two surfaces. I don't have to manually discover or manually find out the distance that this plane should have from this edge over here. What I will do here is that I will simply select the faces about which I want to create a mid plane and click on this mid plane option over here. This is how you generate a mid plane. Let's say I want to generate a mid plane between these two. That would be same. For that, I will go to this first reference, select this as my first reference, and you can see that again a mid plane is being generated, although I have not altered my second reference. You can see here that it is a mid plane between these two faces. Now let's say I want to generate a mid plane between these faces over here. Again, you can see that a mid plane is being generated, but now it is at the mid plane, but this mid plane is at an angle. As these two faces were perpendicular to each other, the only option to create a mid plane over here is to create a mid plane at an angle. These are clearly 90 degrees, so this plane created over here is at 45 degrees. This is where I told you have to play with your options and find out the right one that suits your need. I am just showing you how different types of planes can be created using all these commands that have been shown over here. Going forward, we have one final type of plane creation that I will be showing you with the example that we were creating, that is our problem statement for this exercise. I will switch back to the previous window. Once we are back here, we will create our steering wheel and move forward with it. Now what we have to do is that we have to first create a path for our first we have to create a path for our spoke, that is a line connecting these two surfaces, that these two bodies that we have modeled. For that I will go to front plane and then sketch on it. I will press Ctrl 8 and set it normal to the screens. Here first we have to create a path. I will go into the line command and start sketching from the center point of the slot. I have kept this sketch shown in order to use the references from our previous sketch. First, we will create our path for the spokes. I will tell you why I am calling it a path. First, I will select the line command and start my line from the center of our slot over here. I will create a line like this and then get my cursor back to the end point and create an arc. Again, I will take my cursor away and bring it back to the end point to create another arc like this, and I will end my line on the center point of this geometry or this edge that is being shown. Here you can see why we made our snapping on from the sketch settings as I had shown you previously in one of the videos. Here I will end my line on the center point over here and then press escape in order to end it. Now we will start defining our sketch. For that first I will be giving this diameters. I will get into smart dimensions command and give it a diameter of 35 millimeters and again a diameter of 35 millimeters here. Once I have done this, what I will do is that by using my box selection, I will first select these two entities and then set them tangent. After I have done that, I will make this line horizontal by selecting the line and selecting make horizontal from here. Once I have done that, what I will do again by using box select, I will make these lines tangent. Now that I have done this, I will specify the angle for this line over here. I will get back to smart dimensions, select this line and select the edge over here. I will give it a dimension of 20 degrees. Now you can see that our lines have been defined. In order to completely define our sketch, we have to specify the dimension of the flat face that we want here. Let's say I want a flat face of length 25 millimeters. Now you can see that the path for our spoke has been created. I will press Ctrl Q and exit the sketch and rebuild the part. Next here, I want the feature or the profile that I want to sweep across this path. For that we have to create a plane, and this is the final type of plane that I was talking about. I will go to the drop down of reference geometries and select plane. Now I will select the first reference as this line over here and the second reference as this point over here. As you can see, this one. You have to carefully select the point and you can see here that it is creating. Now I will start sketching on this plane as we used to do for any other plane. I click on plane and then select sketch. Now that we are into the sketch mode, I will press Ctrl 8 and then start creating my sketch over here. For this, we would be again using a rectangular profile. You can see here that the origin for this plane has been placed at the center of the point we selected. If I rotate it, you can see here that the origin has been set at the vertex that we had selected. Again, I will press Ctrl 8 and set it normal to my screens. I will use the spacebar in order to align it. Now again, I will go to the sketch tab and select center rectangle from over here. I will simply draw a rectangle from this as my center. Once I have drawn the rectangle, I will get into the smart dimensions command and start defining it. I want the height for my rectangle to be 25 millimeters. I want the width for my rectangle to be 40 millimeters. I will enter both of them. But now this rectangle is still not defined. we have to define the center point of this rectangle. For that, I will rotate the part and then zoom in over here. I will select this edge over here, this vertex over here, and then select the center point of a rectangle. I will leave the control key and make them coincident. Now you can see that the rectangle is completely defined as all the necessary parameters have been entered. I'll click OK and then add some fillets over here. In order to add an fillet, I have to select an edge. If I don't want to select an edge, I can also select these two vertices or these two lines over here. For example, if I show you in this case, you can see that the fillet or the same fillet has been added. I want the fillet size to be 3 millimeters. Now I will select all the other vertices of our rectangle and then click on OK in order to generate our final sketch. If I press Ctrl Q, you can see that we have exited the sketch mode and revealed the part. Now here I will introduce you to using sweeps. For that, again we'll go to features and select swept boss base from over here. Here it is asking for two inputs. One is our profile and the second one is our path. Now you know why I was referring to this line as my path. I will show you how this works. For this, I will select my sketch, I will select my rectangular profile as my profile, and in order to specify the path, I will select this line that I have created. You can see that this is how my spoke would be looking for the steering wheel. Once we have seen the preview and we are happy with it, we can press OK. But if you zoom in here, you can see that it is not being created properly. For that, I will go to the options and expand it. From here, I will select align with end faces. As soon as I have selected this option, you can see that it tried to align my endpoints with the face that is being intersected with my geometry or my sweep. Here we don't have an issue because the center point is in the material over here. Now that I have entered all my input parameters and the end conditions are well satisfied here, we can click on OK and generate our sweep. You can see here that this is how our steering wheel is looking like. Now all we have to do is that we have to use the circular pattern in order to pattern this sweep for 3 instances. This is simple. You have learned how to use a circular pattern in the previous videos. I will go to the drop down and select circular pattern from over here. Now in features, I will select sweep. You can see that it has been added over here, and for direction, I will click on the tab over here and select the axis over here that we had created in the first sketch in order to create our first revolve. I want 3 instances to be created, so I will enter 3 over here and I want them to be at equal spacing. If I click on OK, you can see here that this is how our geometry or our steering wheel has been modeled. If I press Ctrl 7 and set it normal to our screens, you can see here that it has taken the final form. But there is one aspect that we have not yet modeled, that is the name over here. For that, what I will do is that I will start sketching on the top plane. Here I will go to the top plane and start sketching. I will press Ctrl 8 and set it normal to my screen. Now in order to create an emboss, what I have to do is that I have to specify a curve. For that I will select a center point arc. I will start a center point arc from the center or our origin. I will start it from over here and I will create an arc, something like this. Let's say this is my arc and I will use this as a reference to enter my text. For that, I will have to make it construction so that it is not a part of my 3D model. Now I will give it a dimension. I will give it a radius of 55 millimeters. You can see here that this is how it has aligned itself and our sketch is now fully defined. What we will do is that now we will add text over here. I will select text from our sketch entities and first I will select the curve that I want my text to be wrapped around. For that, what I will do here is that I will enter my text. let's say Solidworks. Once I have entered my text, you can see that the same is being reflected over here. What I will do is that I don't want document font, so I will untick it and I want to increase the spacing between my letters. So let's say from 100 we will make it to 200, and we'll click on font and specify our font size as say 26. If I click on OK, you can see that this is how our SolidWorks has been adjusted according to the parameters that we have entered. We increase the spacing, that is clearly seen over here, and we also increase the font. Let's say we want to increase the font furthermore. We will select 36 and click on OK. Now you can see that it has again adjusted itself. Once we accept the input parameters that we have entered, we will click on OK, and you can see the sketch has been generated. But even though the sketch has been generated, it has not yet been embossed. Now I will press Ctrl Q and exit the sketch and rebuild our part. For that, I will select the latest sketch that we have created, sketch 5. If I specify sketch 5, you can see that in the wrap parameters, the source sketch has been added. Now it is asking us on what surface do you want to create your wrap. For that, I will specify this surface. And now we have three options over here, that is emboss, which works like extrude. We have deboss, that works like cut extrude. And in the end, we have scribe, which is similar to deboss. For this, we will select analytical. You also have spline surface, but since our surface is flat, we can use analytical. Once we have entered all our parameters, and the last parameter that we have to enter is the amount of extrusion or emboss that you want to add. Let's say we want to add an emboss of 0.5 millimeters. Once I have entered all my inputs for wrap, I will click on OK, and if I zoom here, you can see that the text has been added, and rather my text has been embossed. If I press Ctrl 7, you can see that this is how my sketch has been created. We have successfully created a steering wheel. But before concluding, we have to hide all the sketches that were shown before. This one also, it is a good practice to hide your planes, as they are not important, or rather they are not important in the visible aspect of your 3D model. They are very important in order to create the models, but it is a good practice that you hide them at the end. If I press Ctrl 7 and set it to isometric, you can see that our 3D model for the steering wheel is now created. I hope all the features that were taught to you in this video, from sweep and creating planes and also using Revolve command, that was the main highlight of our video or our exercise, was very clear and you understood all the aspects of it. I will see you in the next one. Thank you.